This is TWIS, This Week in Science, episode number 1067, recorded on Wednesday, July 15th, 2026. Uncanny Science. Hi everyone, I'm Blair Bazderich, and today we will fill your head with the cinema, screen time for primates, and koala cures. But first...
Thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer, disclaimer, disclaimer. The only constant in this world is change. Friendships fade, children grow up, historical knowledge shifts, the hip becomes passé. Decay, consumption, conflict, they are all part of life. In many ways, it is what makes life truly beautiful. Yes, nothing stays the same. Nothing is forever. Well, except for maybe a certain podcast, perhaps? One that persists year after year, dedicated to the dissemination of the latest science news. The players may rotate, the format may shift, but one thing is for sure. You can count on This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, minions. Everyone listening, watching, everyone joining me here for science today. I'm Blair. Welcome to This Week in Science. Thank you for joining us. We have a great show ahead. It is perhaps a little bit abbreviated. I am the only host, once thrice of us, now just one. Kiki is off doing amazing things. She will be back, of course. Our dear Justin is still just living his best life in a lab in the evenings, or is it early mornings now? I don't know. But regardless, you'll see us all again at various moments. We come in and out, but we are all dedicated to this wonderful show called This Week in Science. This week, I actually brought 4 stories, one that is not part of the Animal Corner, and then 3 for the Animal Corner proper. If you are joining us for the very first time, the Animal Corner is kind of my bag. I'm a zoologist. So I brought stories about, as I mentioned, the cinema culture and what it does to your body, the Uncanny Valley for primates, koala cures, and a new relationship in the ocean that we did not know about before. Caught on tape. So anyway, as we jump into the show here, I want to remind you that subscribing to TWIS is the best way you can support us. That you can subscribe on your favorite podcasting platform or on YouTube or Facebook if you enjoy looking at our beautiful faces. And you can also just search for This Week in Science or go to twis.org and click on any of the various icons for your favorite way to consume media. But now it's time for science. Now, usually we would have at least 2, if not 3 of us here, sometimes 4 if there's a guest, and we could all kind of ask questions and have a discussion about these various articles that we brought today, pieces of science news. Since it is just me today, I'm going to tell you what I learned. And I'm going to be looking to the chat, to all of you who are listening or watching live, to let me know if you have any questions or anything that you want to add about these particular stories. So I'll be monitoring that. But otherwise, you can always hit us up via email or social media. More on that at the end of the show. And you can let me know what you thought. But for now, let me go ahead and jump into my first story. So I'm actually going to kind of tell you what the log line for it is, like what the main crux of it is, and then I'm going to read you the very last sentence of the article, because I think it really gets to the crux of things. And I know that this is like, I'm jumping all over the place, but the idea of this new piece of research out of Tokyo, Institute of Science, Tokyo in Japan, they have conducted the first longitudinal study examining the association between cultural engagement and physiological age. And they did their best to control for unmeasured confounding factors that do not change over time, things like socioeconomic status and stuff like that. And as you might imagine, overall they found that cultural engagement, going to the cinema, museum, or theater, is associated with a younger physiological age. I'll get into how they did this in a minute, but I'm hoping that most of you had the immediate thought that I had when I first read this article, which is the cultural connection making them younger, or do they have more cultural connections because they feel younger? If you feel bad, you're not going to want to go to the theater. If you feel young and vibrant and healthy, you want to go to the theater. So I do think that there is a potential for kind of the inverse causation here. And so this is one of the things that one of the researchers said at the end is, this study is observational. There is no firm conclusions that can be drawn about cause and effect. We acknowledge that the findings could be explained by reverse causation, whereby individuals in better health are more able to take part in cultural activities. And so that was what I thought of immediately. But nevertheless, they're saying that there's a connection, right? And that's ultimately what this is. It's an observational connection based on survey data. Participants, they looked at about 1,900 adults who looked at a longitudinal study of aging, which is an ongoing population-based study following a nationally representative sample of adults 50 or older living in England. And they collected data on at least 2 occasions, either in the 2004-2005 year, the 2006-2007 year, and or the 2008-2009 year. So they collected data twice. They looked at 10 physiological markers: pulse pressure, diastolic blood pressure, forced expiratory volume, hemoglobin concentration, fibrinogen, glycated hemoglobin, low-density lipoprotein, cholesterol, body mass index, which again, BMI is bunk science, but that's okay. We'll gloss over that one. Grip strength and walking speed. And they used all of those data to produce a composite physiological age score. So based on all these other measurements, how old are you physiologically? Then they also had them complete a questionnaire that asked how often they went to A, the cinema, B, the music or art gallery, and C, the theater, a concert, or the opera. For each item, they selected a response on a scale from 0, never, to 5, twice a month or more. And that created a composite cultural engagement score from 0 to 15. And so those with high cultural engagement, which means they did something every few months or more, had a physiological age of 66.9 years. The lower levels of cultural engagement had a physiological age of about 69.9 years. So it was a difference of about 3 years, which might not feel like a lot, but when you are in your 60s, I would argue it's a lot. Individuals with higher levels of cultural engagement tended to be women more than men. They tended to have higher socioeconomic status. They had paid employment and had better health conditions. So a couple things there. Also, like, do any of these factors impact their social interactions? And do those then impact their levels of cultural engagement? Because we also know that social engagement or social activity also influences your physiological age for the better. Like, it makes you younger to be social. And if you are alone a lot, it actually helps your body to age faster. So all that to say, like, there's so many when you're dealing with a survey of real humans There's so many things going on to make that human a human. They don't live in a lab. You can't control variables. And so how do you know what causation is? Which is why the authors repeatedly said that they could not indicate causation in this. Really, you need to it would be great if you could like take two people in a vacuum and then make one never leave their house and make one have social interactions and then make one have social interactions and cultural engagement. And then you could kind of say like, what is actually influencing this person's physiological age? But yeah, so I think that I'm not saying it's completely off base. I think that it would also make sense for it to be true that cultural engagement could impact your physiological age because it's a social interaction. It is a reason to get out of the house, but it also makes you use your brain and it makes you remember things and you have to get dressed, sometimes fancily. I just went to the ballet last weekend. Everybody dressed up. It was lovely. I saw the Dracula ballet and everyone was dressed just so amazing. Like, I know it's very passé to say now, but like they understood the assignment. Like everyone was like in red and black and top hats and capes and just everyone looked fabulous. But it was definitely a moment where people kind of got together in kind of a shared goal of a particular cultural phenomenon and enjoyed that together. And I do think that it was stimulating, it was enriching. My serotonin went up for sure. It made me happy. So if these are things that make you happy, that can also help influence your health. And so I don't think it's completely off base, but I do think that there needs to be a lot more clear lines drawn between the two to make sure that, again, it's not a reverse causation, that there's not something else happening that's related. So, but in the meantime, yeah, go ahead, go to the movies, go to the theater, go to a concert. It could help your health. Yeah, so I just wanted to see what anyone said in the chat about this. Yes, couldn't it be that younger people have more time to go to the theater? So Brian, the idea there is that it's not that their actual age was 66.9 versus 69.9. It was their physiological age. So they controlled for age. So basically, hypothetically, a 67-year-old person, this 67-year-old person measured to be 69, and they didn't have as much cultural engagement. And this 67-year-old person measured to be 66, and they did have cultural engagement. That's what they're measuring here, is that the same person at the same age, where they tried to control so that the only difference is how often they go to the movies or the theater, they presented younger than the ones who didn't. And somebody else says dirt comes to mind. So flying out, do you mean like it's boosting their immunity because they're around other people? That's like another thing related to the social engagement and just being around other humans being a really important part of staying healthy. Yeah. Vampires make me happy. That is accurate. The Dracula ballet, I suppose it did suck. But in the best way possible. Fada wants to know, what about when you go to the movies or theater and it's a tragedy and you have a good cry? So there's also a catharsis to crying. And I think we've talked about it on this show before. There have been studies that have shown that crying can actually be healthy. It's like a release, and it can be helpful to your mental health to cry. But I would also argue it just kind of helps with stretching the emotional muscles, stretching the brain muscles, having a mutual experience. Those are all things that can be beneficial to us as social creatures. Movies aren't theater, they are movies. Yes, that is why they said the cinema was one option. So what were the three options again? So option A, how often do you go to the cinema? They're British, it's in England, so they call it the cinema. B, a museum or art gallery, or C, a theater, concert, or opera. So they likened a concert akin to theater, akin to opera, which I kind of get, but I also, concert there's a valley in between the $12 show with the sticky floor and a giant show at an amphitheater for Paul McCartney where you have a seat, right? Like those are very different, but perhaps you get a similar sense of satisfaction out of them. I used to love those live concerts that I used to go to. How'd you establish if the effect has a direction? So, Paul, the way that you would do that is you'd have to create some sort of experimental design, right? You'd have to say that, okay, the same people with the same level of health going into the experiment, we gave one of them an opportunity to go to the theater, and we gave one, they had to stay home. And that one, the one who went to the theater, ended up presenting as physiologically younger. Then you know a direction, because they had the same starting point, and the only change was how often they went to the theater. The only change was the cultural engagement. If it was the opposite, it would mean that we had a person who was healthy and a person who was unhealthy, and we gave them both free tickets, and only one of them went to the theater, and it was the healthy one. That would be the direction, saying that your physiological health indicates whether or not you engage in cultural institutions. So hopefully that makes sense. Okay, so that is what I brought for my non-Animal Corner story this week. Hopefully the next time any of you go to the movies, the cinema, or the theater, or a museum, you can think about yourself as, I don't know, maybe I'm de-aging myself physiologically by being here today. All right. So next we are going to move into certainly my favorite part of the show, Blair's Animal Corner.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels. There's Animal Corner.
Do I say it to myself? What you got, Blair? Well, in the Animal Corner today, I have a few different stories. My mouse is deciding not to work. Okay, here we go. So this first one I thought was really funny. So we're all hopefully familiar with the Uncanny Valley. The Uncanny Valley is the space where, we see a cartoon or we see a crude animation and we can recognize that's a cartoon or a crude animation, or it's kind of artistic. It's not supposed to be realistic looking. And we can see a hyper realistic rendering of a human, like with a lot of the AI representations going on now. And we can potentially be fooled by it and think that it's real. The Uncanny Valley is this area. It's actually very close to real looking human animation, where it just looks slightly off and it makes you feel kind of uncomfortable and almost kind of avert your eyes. You don't like it. So the Uncanny Valley is like almost but not quite looking correct. And so I am here to tell you today that primates also have their own Uncanny Valley when it comes to CGI macaques. This is a study from the University Clinic Tübingen in Germany and colleagues at KU Leuven in Belgium. They looked at a new tool which allows researchers to create realistic full-body animations of monkeys. And in their creation of that tool, they found that there was an Uncanny Valley phenomenon when it came to how these monkeys were responding to that tool. So let me kind of set the scene. Macaques, they're social creatures. They use facial and body signals to communicate. Their visual system is also very similar to humans, and so they're often a test case for certain communication methods that we want to test kind of on a blank slate, different from, humans with full language and knowing that they're receiving a stipend for being in a study, right? Macaques are commonly used in neuroscience for that reason. They're also used in psychology and behavioral research to understand social behavior and specifically perception of these things. And so when they're trying to use them in studies for social behavior and perception, they often want to provide a visual indication of a way a monkey is acting. Or specifically, like if they could, it would be great to give one macaque direction and say, now treat that other macaque this way. And then you can see how the other macaque responds. Obviously, macaques are not studied actors, and so we cannot just give them a command in language and tell them to do something. So instead, the goal is to create some sort of 3D avatar. Then the monkeys can watch the way two macaques interact on a screen, and you can watch where their eyes go, how their brain responds, how they physically respond to kind of the scenario that they're watching. But the way that we usually make 3D avatars, particularly for like Hollywood and stuff like that, would be to use body markers, like those crazy gray and black suits with the little tennis balls all over them. We can't do that for monkeys. So you need to kind of bridge the gap of like, we know what macaques look like. We have videos of macaques acting and moving, and we know how their body moves, but we can't say, okay, macaque, now do this and we'll capture it. So they wanted to make a monkey avatar. They developed a tool called Mac Action, which uses deep learning. Yes, this is a form of AI as it's currently used. I know it's not really artificial intelligence. Deep learning. So it's a machine learning method that basically has like a synthetic neural network. Like they basically use nodes like in the brain. But anyway, too far down that hole. They use deep learning to generate a realistic avatar from multi-camera video footage of monkey movement. So they basically were able to feed video footage into this AI and have it make a macaque that then they could put in commands, and the macaque could do what they wanted the macaque to do, and the macaque would move like a real macaque. To test the realism of the avatars they made, they showed 8 male rhesus macaques videos of real monkeys and then the animated avatar. And they were doing the same thing. They measured where, how often, and for how long the monkeys looked at each video. The responses to the real video and the animation were indistinguishable. So it seems like they were fooled. At least in the way that they studied them here, their responses were consistent, which means as an experimental model, it would work. Great. Now, I think this is really funny. They could have stopped there and been like, we made a tool, hooray! But for some reason, the researchers wanted to know whether macaques experience the uncanny valley. They showed macaques variations of the 3D avatar with different levels of realism. First, they removed some fur. Then they removed all the fur. Then they changed the color. Then they changed the texture. And they measured the response from the macaques. They found that the monkeys fixated less often on avatars with intermediate levels of realism than on both the unrealistic avatars and the highly realistic ones. So they had a U-shaped relationship between attention and realism, very, very similar to the uncanny valley effect as measured in humans. So they were like, that's like a cartoon of a monkey. I get it. And then they were like, that's a monkey. And then in the middle, I don't know what that is, but I don't like it. I'm out of here. I think it is wild that this kind of universal experience for humans can be extended to the animal kingdom. I love it. I actually do think that this is one of those maybe rare examples of a use of AI in science that I think might be really useful. Because we know that primates are very good at responding to stimuli on a screen. So there's like endless possibilities if you can create 3D avatars of these monkeys. And get their reaction. And I'm really excited to see where that goes. But I do think it's funny that the researchers, while they were at it, were like, oh, while we're here, let's see if they experience the uncanny valley. And I have some theories based on no evidence whatsoever why they might have done that. And I love them all. One of them is they were like, how accurate does this have to be? Can we give them like a really bad animation and see if it'll work? Like, or do we really have to put in the time and energy to coming up with a really good model? Or were they like, oh, is this actually effective? Or are they just responding to everything the same? And so they needed to find a measurement that proved that they were being tricked and they weren't just looking at a screen and responding to things on a screen, regardless of whether they appeared as a monkey or not. And the other, of course, is just like, this could be another paper while we're here, which is a great area of research, I think, the where we're here, while we're here area of research, because you've already put in the effort and the time and the resources, and you have the staff, and you have the people who know how to look at the data. Tack on a couple more hypotheses in there. That's just called efficiency, right? But so there you go. Monkeys can experience the uncanny valley. Where do we go from here? Can fish? Can dogs? I can't wait to find out. All right. Well, next, I have a koala chlamydia update. This one's actually really cool. I think everybody's pretty well aware at this point about koalas and chlamydia. It is actually very serious. When it first started being reported in like the 90s and early 2000s, I think people thought it was really funny. It's like, chlamydia. But it's actually pretty bad. Koalas can have a severe like conjunctivitis-like response that can actually even lead to blindness. They can have infertility. They can have reduced immune systems. They can have cognitive problems that lead to further predation. And so there's a lot of results that are from being infected with chlamydia. Also, it spreads really quickly, partially because they have a cloaca. Well, not quite a cloaca, but they have something like a cloaca. So they basically have an all-in-one opening like a lizard or a snake might have, which means that pee and poo comes out the same hole that babies come out. And that means that there's an opportunity. Wait, is that right? No, that's not right. They're mammals. I definitely got that wrong. But there's for some reason, I'm going to look it up. For some reason, marsupials possess a modified partial cloaca. Okay, so I was right. So that's so funny. That was like banging around in my head, and it was accurate, and I just started to second guess myself. But yeah, so there's an opportunity for fecal material to mix as the babies are leaving the birth canal, and that means that a lot of joeys are born infected with the chlamydia as well. All that to say, it spreads really quickly, it's really insidious, it's a big problem. There are certain areas in Australia where a general population of koalas, 70% of them will be infected. So there's been a lot of research, a lot of efforts to try to figure out how to treat this disease and also prevent further spread. They've had some really good success over the last 5 years or so inoculating wild koalas with vaccines. The main problems with that, though, is that you have to catch a wild koala and not catch the same one over and over again. But also the most effective vaccine that they've developed to date is a 2-shot vaccine. Like a lot of the COVID vaccines that we first got. You have to have a shot and then you have to have another shot 30 days later. So because of that, they have to not only catch a koala and give it a vaccine, they have to catch the same koala 30 days later and give them the vaccine, which at scale, inoculating an entire population of koalas, really, really difficult. The other problem is that chlamydia, like the flu, can mutate and there can be strains that are dominant in a given year. So if you don't get a good handle on the spread, you're back at square one later on when there's a new variant. If you can vaccinate enough to reduce spread, specifically to joeys, to the babies, then by the time a new strain comes, infection levels won't be as high. You might be able to get ahead of it and prevent spread by inoculating early. So the study that I wanted to talk about this week was actually, it's less of a study and more of a case study of a single koala that was the first ever to receive both shots at once, but the second was in a time-release capsule. This was a young koala named Bamsi. It's a Norwegian word for teddy bear. She is the very first to receive, this 18-month-old female received this 2-part vaccine. So she got her first dose, and then she got an implant under the skin. It's designed to break down after 30 days and then delivers the second vaccine dose in a burst. The casing on this vaccine that breaks down over the course of 30 days is all just made of naturally occurring molecules and things found in your body, so it's totally not harmful. They ended up doing 5 koalas total, and they have recaptured 2 of them, one of them being Bamsi, and both are chlamydia-free a month later, which is a really good sign. If they only had to catch a koala once, there's a much better chance of getting a handle on this thing. It's also cheaper, it requires less human hours, and there's less chances of accidentally catching the wrong koala at the wrong time. There's also a better chance of them passing on immunity to their babies because they're getting that second release right at the 30-day mark. They have vaccinated about 500 koalas total through some of the rehabilitation centers that they have in Australia, but that is with the 2-shot method. And so far they've found some really good success just with those 500. So if they can expand at scale and really look at vaccinating entire populations, this could be really huge, because the area where they've been doing these mass vaccinations, they've reduced chlamydia admissions to the hospitals when they bring in infected koalas by 75%. And as far as they can tell, a bunch of joeys and grand joeys have been born to populations that were basically heading towards being completely sterile. So we're seeing an uptick. I can't believe it. It feels like we might actually be able to save koalas from this terrible chain reaction that's, a bunch of things, but some of it's habitat destruction, some of it's climate change, some of it's like introduced predators pushing them into different areas, some of it's just nature being nature and develop, evolving new strains of things. But at the end of the day, this is a really, really cool development that might save koalas in Australia, which, Australians, they're pretty proud of their animals, but in particular, their koalas. They're amazing animals, and they've made it through a lot of evolutionary history, and to be felled by chlamydia would be such a bummer. This really cool method for vaccination, also I'll mention, has a lot of potential applications in wildlife biology. I can already think of some, but if any intramuscular vaccine could be delivered via a time release, and you can do 2 shots at once, just in captivity, it's going to reduce the amount of stress on an animal. They won't have to be anesthetized as often, which would be a huge benefit, especially if they're older or they have health concerns where anesthesia is dangerous. But also if you're trying to, give birth control to animals out in the wild that are invasive, or if you're trying to treat a disease that is getting out of control, like chlamydia and koalas. There are other ones out there impacting animals. That this could be a huge breakthrough for conservation for a lot of animals if you can do a time release second dose of a vaccine and be effective. Yeah, so Brian, we could use this on other species and or diseases. I'm already thinking like humans too, right? Wouldn't that be cool? We wouldn't have to go back to the doctor. Yeah. Oh yes, and John Oliver has contributed to this issue. I am aware. He bought some items from Russell Crowe, and then I think Russell Crowe opened the wing, the koala chlamydia wing, which I love. He's very proud of it. All right. Well, I have one more story tonight. And this is about a brand new underwater relationship. And I mean relationship in the the strict definition of the word. Two animals in common space having an interaction. This is in the Caribbean. This is on coral reefs, and researchers have found a tube worm called a Christmas tree worm interacting with coral reef fish. Tube worms, they have this kind of calcareous tube that they're in that protects them. So they secrete the tube. So they're like a little larva. They find a nice little coral to settle on. They bop on there. They fuse to the coral with their little foot. And then they build a tube around themselves. They stick the top of their tube out to filter feed. And sometimes it looks like a pen, like a giant sea pen is a tube worm. Sometimes it looks like, in this case, a Christmas tree. So it's called a Christmas tree worm. But they'll stick that out and they'll filter feed. And if anything dangerous comes by, they pull it back in. They are very protective of it, also because for many tube worms, those are also respiratory organs. And so they want to protect those organs because that's how they feed, but also because that's how they breathe. So if somebody tries to nibble it off, if somebody gets it too dirty, that can directly relate to their survival. So they suck it back in. And a lot of tube worms, including the Christmas tree worm, has a kind of a lid. I already forgot what it's called. It's I'm going to find it. They have a little lid that they pull in, and it covers up the top of their tube. And let's see. I'm going to find it. Operculum. Okay, so it's like a little plug. And so when they pull in their radials, which are their the Christmas trees that help them breathe and also eat, the operculum pops on the top of their tube. It secures the hole, and it also sometimes will have little spikes on them. It's just like, leave me alone. So the idea of a fish hanging out in the radials of a tube worm. Now that should sound against everything I just told you. They wouldn't want that. They wouldn't want to get their radials dirty. They wouldn't want a fish nibbling on anything. They wouldn't want it impacting their ability to filter feed. It sounds totally against kind of the goal of those structures and the point of being a tube worm that can suck yourself in and protect yourself. But these researchers just kind of stumbled across coral reef fish hanging out in the radials of the Christmas tree worms. So then, I love this, the lead author on the study, Morgan Bennett Smith, who's a PhD candidate at Boston University Marine Evolutionary Ecology Laboratory, noted the behavior, found it to be very strange, and also found some earlier research actually, Morgan Bennett Smith did the research earlier where they also found something very similar between fish and worms in Papua New Guinea. So this is like the second time they found it. They're like, this is really interesting. And essentially sent undergrads diving to coral reefs to just watch and see if they could find this more and more and more. So a group of undergraduate researchers documented neon gobies with the Christmas tree worms through diver surveys. They swam all over the coral reefs. Shucks, what a tough undergrad, right? And stopped for 10 minutes when they saw the fish and worms together and recorded their observations. They found that these interactions actually happened quite a bit. And it has it's a fundamental part of the coral reef. It happened enough that they're like, this is a totally normal thing happening time and time again in these coral reefs. So they have no idea what the relationship is. They don't yet know what one gets from the other. They don't know if it's a mutual relationship where they both benefit, a commensal relationship where one benefits and one is neither hurt nor helped, or if it's a parasitic relationship where one is helped and one is hurt. So they need to look into that. They need to figure out, like, why are you guys doing this? Who's benefiting from it? And how is this happening? Because, like, the tube worm has a very easy out here. It can just pull itself back in. So why is this fish allowed to hang out there? Is it something like the clownfish in the anemones? Is it cleaning the tube worm radioles? Is the fish bringing food in some way? Like, the first thing that I thought of was, like, is the fish pooping and there's nutrients in the poop that then gets delivered directly to the Christmas trees since they're filter feeders? I don't know. They need to look into this, and they're very excited to do so. This group of researchers, but this is from Boston University. But I also just love the idea of, like, I'm an undergrad and I'm hanging out in this lab as part of my undergrad experience. Hey, you go swim in the coral reef and see if you see any fish in the tube worms. I love it. Yes, they're small fish flying out. Christmas tree worms are very small. So next time any of you go snorkeling or scuba diving in a coral reef, look out and see if you can find a tube worm with a little fish inside. All right. Well, believe it or not, I've talked for almost an hour. Those are all the stories that I brought. I'm checking the chat here. I feel like I've answered all the questions. I've informed you all. And so I think it is time for us to wrap up the show. I do have a couple plugs before we close things out here. While Kiki is not here with us today, she will be doing a special interview on Friday, July 17th. That'll be live at noon Pacific time in all of the usual places. So YouTube, Facebook, Twitch. Go to twis.org. You can figure it out. But she will be interviewing Jeremy Pollack. His book, Wired for Peace, Using 7 Neuroscience-Based Principles to Resolve Conflicts, is a book all about the first comprehensive book on the neuroscience of conflict resolution. So that should be pretty interesting. I know there's a lot of opportunities for conflict and discourse these days, so that should be an interesting interview. I will have a special appearance on the Daily Tech News Show tomorrow. So that will be Thursday, July 16th. That's at 1 p.m. Pacific time or 4 p.m. Eastern. You can watch at youtube.com/Daily Tech News Show or twitch.tv/Daily Tech News Show. You can also go to dailytechnewsshow.com to listen to it afterwards or find that in all of the various podcast locations. I will be talking about AI being used for zoology. So I may bring up this Uncanny Valley situation tomorrow. We'll see. But I'm also going to be talking about whale songs and some other applications of AI that are more than just folding laundry or scamming people out of money. Anyway. Oh, and I'll also be promoting my other show via that, which is the Fantastical Field Guide. So, thank you all for listening. I do hope you enjoyed the show tonight. I know it's a little bit different from our usual format, but hopefully it was enjoyable and you learned something new. Shout outs to Fada for his help with our social media and show notes, Gord for manning our chat room, Identity4 for recording the show, right? Rachel, thank you. Hopefully I didn't give you too much to edit out this week, but you are so helpful in your edits of this show to package it for the podcast listeners. And I'd also like to thank our Patreon sponsors for their generous support.
Thank you too. Aaron Anathema, Adam Mishkan, Alan Viola, Ali Coffin, Andrew Swanson, Artem, Arthur Kepler, Bob Calder, Bob Coles, Brendan Minish, Brian Carrington, Chris Wozniak, Christopher Dreyer, Christopher Rappin, Craig Landon, Craig Potts, Daryl Myshak, Dave Wilkinson, David E. Youngblood, Derek Schmidt, Don Mundis, E.O., Eda Mundell, Eric Knapp, Flying Out, Fredis 104, G. Bird Lattimore, Greg Briggs, Jack, Jason Olds, John Atwood, John McKee, John Ratnaswamy, Johnny Gridley, Ken Hayes, Kent Northcote, Kevin Parachan, Kevin Reardon, Kurt Larson, Lon Makes, Lauren Gifford, Mary Gertz, Marjorie, Mark Hasselglow, Mark Jenkins, Noodles, Patrick Peccaro, Paul D. Disney, Paul Ronovich, Philip Shane, Pierre Velazar, Richard Badge, Robert Norland, Robert Farley, Rodney Lewis, Rudy Garcia, Remy Day, Sean Clarence Lamb, Shu Bruce, Stephanie Embry, Stephen Albaran, Steve Leisman, a.k.a. Zima Sue Doster, Teresa Smith, Tony Steele, and Vegard Schefstad.
Thank you for your support on Patreon. If you're interested in supporting us, you can find information at patreon.com/thisweekinscience, or you can go to twis.org and click on the Patreon link. On next week's show, it will just be me again, but I will have an interview with a wildlife biologist and natural resources professional. She specializes in native and invasive species in California. I actually am excited to talk to her about feral pigs, especially in light of the episode we had about a month ago about the latest research on feral pigs. So we will be talking about that next week, Wednesday at 8 p.m. Pacific time, and we will be broadcasting live from our Twitch, YouTube, and Facebook channels. Do you want to listen to us as a podcast? Maybe while you drive your commute, bake a cake, reorganize your sock drawer, who knows? Just search for This Week in Science or where podcasts are found. If you enjoyed the show, get your friends to subscribe as well. For more information on anything you've heard here today, show notes and links to stories will be available on our website. That's at www.twis.org. And you can also sign up for a newsletter, which I do feel like there's going to be one soon. We love your feedback. If there's a topic you would like us to cover or address or a suggestion for an interview, please let us know on one of our social media accounts or send us an email. Just be sure to put TWIS, TWIS, in our subject line, or our email will be spam filtered into the radials of a sea pen and sucked back inside that tube, and we'll never hear from it again. We look forward to discussing science with you again next week, and if you've learned anything from the show, remember, it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world, so I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice, show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand, and all it'll cost you is a couple of grand. 'Cause this week's science is coming your way, so everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.